Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at lesson 6.1.2. This is one where we are going to focus on a coordinate grid or a graph to help us with our translations in identifying the points. And we've got a resource page that you can use. You're going to be creating your own graph, so you're going to need graph paper and a ruler for this. And there's still the online tool that we can use to kind of help us with the process while we're working with the resource page. So let's just get to it. It says, have you ever had trouble giving directions? Sometimes describing where something is or how it is moved is difficult. For this reason, people often use coordinate graphs like the one shown at the right. In fact, if you think about it, every map, the globe of our representation of our planet is superimposed over a coordinate grid for this very purpose. Those longitude and latitude lines are essentially a coordinate system. Coordinate graphs help you describe directions with the words like left or down. It can also help you measure distances. Today, you will work to describe movement on a coordinate graph. You will also look at ways to describe where an object is on the grid before and after a transformation. As you work, use the questions below to help start math discussions with your team, where you're not working with your team, but just thinking on your own. Is there a different way to get the same result? Did we give enough information, and how can we describe the position? Okay, so here's just an example. We're not going to do any work with this, but if we were going to describe how to go from this graph here to its image up here, the first thing we might consider doing is maybe reflecting it. And so, we can do a reflection. And I think what we will notice as time goes by is that you're going to have a line of reflection, which is like, this would be like the line of reflection right there. Think of a mirror as a line of reflection. And then every one of these points, when you reflect, however many units it takes to get to your line of reflection, you're going to go the same number of points across. So this one only takes you one step, so you go one step across. This one is touching the line of reflection, so its reflection or image will also be touching. And this one goes 5 units to get there, 5 to go beyond. And so we'll get more into this process, but this problem right here really isn't one of the problems that we're working with in this lesson. So let's just move on. But we're basically going to be charting movements across a coordinate grid. All right, so while solving the key challenge puzzles in 6.1.1, Rowan made more than one move to change his key from point A to point B. That's point A to point B, and from point C to point D. Now, both of these have been superimposed over the same coordinate grids, but when if you would have done these happen to be the challenge problems from 6.1.1. And there's a little bit of a mistake there. I should probably get that fixed. Hold on for a second. I can't stand seeing that there. This is a mistake. I'll be right back after I fix that mistake. Okay, much better. When I first downloaded all this, resource page that came along with this and this little picture right here was wrong. And so now we've got it right. So glad I was able to get that fixed. Okay, so you're trying to get from point A to point B and from point C to point D. And I guess, where was I when I left off? Oh, I guess Ron was coming up with a couple of different ways to do those moves, okay? So our task is we're gonna you can use this resource page here that's attached to the classroom, or these are actually key lock puzzles, challenge 1 and challenge 2. So notice where A is and the wall is right there. That corresponds to this puzzle here that you can access using the online book. Okay, get rid of that. And challenge 2 is this one right here. Okay, so you can use this and use the tools to get from here to here. And what you want to try and do is do it 2 different ways and record the steps that you do, just like we did in yesterday's activity. And so where do I want to go? I want to come back here. And so just remember that when we do this, you've got 3 choices. You could either do a turn, which requires you to rotate a certain number of degrees, whether it's 90 or 180 or 270 degrees, either clockwise or counterclockwise, and you have to do it over some point. So this point right there is at 5, x is 5 and y is 4. So if you wanted to do a rotation there, technically you could go like 90 degrees in either direction, but you couldn't go 180 degrees because the key would hit that wall. But at any rate, when you do a turn or a rotation, it's a number of degrees and it's a direction and there's a pivot point. What is the rotation point? And that's usually the dot that's right there. You could also have a slide, which we sometimes call a translation, where you're moving it left and right or up or down. And so the number of units that it moves left or right would be measured against the X line, and the number of units that it moves up or down would be measured on the Y line. And if it goes up, these are pluses, or that's a plus. If it goes to the right, that's a plus. If it goes to the left, that's a minus. If it goes down on the Y line, it's a minus. And then the last part would be a flip, which is that reflection over a line of reflection that is defined either on the x-axis or against the y-axis. And so we'll just practice this a little bit. In the flips over these lines, generally that's the one that gives students the most confusion. And so we'll just have to work on it and practice it. And the more times you do it, the more you get used to it and the quicker you will learn it. So this is the task I would like for you to complete. If you choose to use the online tool, that's wonderful. If you choose to print off this piece of paper, you can do that as well. But I want you to create in your journal a chart. And what you're going to do is you're going to try and figure out how to get this key, which is the red triangle, into this keyhole, which is the blue triangle. And using the triangle, you can see how we're going to have to reorient that key. So in order for it to fit perfectly, we've got to get this point right here, and you got to get these 2 points over here, and there would be the hypotenuse of that right triangle, the longest side. So try and do it in 2 different ways and use the online tool to help you. So here, if you wanted to start with a rotation of counterclockwise 180 degrees, you would not be allowed to do that because it would hit the wall. You would not be able to complete it. You would not be able to do a reflection over, say, x is equal to 3, because you would have to reflect over the wall, and that doesn't work either. So your first step is probably going to have to be to go down first. Now, let's say I wanted to go 10 units to the left and then down 6 units, or let's go down 6 units. You know what's going to happen first here is it's going to want to do the X movement first, and you can't do that. So we're going to have to do this in a couple of different steps, where you're going to have to move down, then move it over, and then you decide how, if you want to reflect or if you want to rotate or how you want to do that. And once you get everything into place, then record in your journal what the steps were, what was the move, and what were the details of that move. Okay, let's just do this one first, and I want you to try and do it 2 different ways. Go ahead and pause the video and try and work out 2 different ways, and then record it, and we'll see how close yours come if you get any of the same moves that I chose to do. All right, so let's see if your moves are similar to mine. I decided to do the first one where I did a slide, and as you saw with the online tool, I can't move to the left without hitting that wall, so I have to start with an x plus 0, which means it stays here. It's just going to move up or down, and I chose to have it move down 6 units. So we go 1, 2, 3, 4, 5, 6 units would put us to here. Okay. Then I decided, all right, let's slide it again, because I would like to get this point on top of point B here. And so that's going to require us to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the left, but not move up or down. So I'm going to go x minus 10 for this one and y plus 0, because I don't want it to move either up or down. And so that's going to take us 10 units to the left. Now, let me actually go back to where I was before for a second. Notice that this triangle has 3 different points, 3 vertices. Each one of those vertices moves the same distance. every one of them moves 10 units to the left. So this one, if I were to actually draw those points in, this point would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and would stop here. This one would stop in the same location, and this guy goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so after moving the entire shape 10 units to the left, that's where it stops. So there's actually a way for you to figure out where the new coordinates will be of this triangle before you even move the triangle. It's like every single point on the triangle has to move according to these directions. 10 units to the left, nothing up or down. And now the last move will not be a reflection, because if I did a reflection, it would end up doing something like this. It would go to here, and that's not what we want. Although I could now reflect it again and get it in 4 moves. But I'm going to have us do it in 1 more move. And that 1 more move is a 180-degree rotation, where every point is going to rotate around 180 degrees. Okay? So think about this for a second. This point right here, you go 180 degrees, it's going to move you to here. This point here, if I color, now let me color it black, would go 180 degrees to here, and then this point would stay exactly where it is. Okay, so that is a 180-degree turn going counterclockwise, right, because I went this way, and the pivot point is where x is equal to -5 and y is equal to -2. So after going through and doing that rotation, this is a little bit clunky. It goes like this, but the pivot point would have stayed on point B at -5, -2. So that is one way where we would do it in 3 moves. Another way we could do it actually would involve 2 different reflections or flips. The first flip, I decided to make my line of symmetry be 1, 2, I think it was this line right here, where y is equal to 1. Okay, so remember, the line is defined by whatever its y-intercept is. So in this case, the y-intercept is at 1. So if we flip it over where y is equal to 1, then every single one of these points is going to go 1, 2, 3 units to the line of reflection. So we'll go 1, 2, 3 across. This one goes 3 to get there, 3 to cross. And this one is actually 4 units away, so it'll go 4 to cross. See how that's going to form a mirror image of that rectangle. So what I'm going to do is I'm going to take a rectangle, and then I'm going to flip it and then move it to that location. So this is a mirror reflection of the original crossing over the line of reflection, which happened to be where y was equal to 1. That is the name of that line. And now we're going to do the same thing, but this time our line of reflection, let me go ahead and move this guy out of there. Come on, let's move you out of there. And let's do another line of reflection that would go across the y-axis, which happens to be where x is equal to 0, right? This is the line where the x-intercept is where x is equal to 0. So every single one of these points goes 1, 2, 3, 4, 5 units there, 5 across. So whatever it takes to get to our line of reflection, you go the same distance across. This one's going to take 8 to get there, so we'll go 8 across. This one is going to take 8 to get there, so we'll go 8 across. And then what we end up having is a flip that goes over the y-axis or x equals 0. So let me go ahead and flip that again from left to right, and it's going to put us there. Okay, so let's go ahead and let me reproduce each one of these using the online tool. The first one said, let's go x is equal to 0 and y is equal to -6. That's a slide where y is equal to -6. Then I said, let's do another one where x went -10, but y stayed the same. And then we rotated it 180 degrees counterclockwise over this point, but we're not going to put in the point, and there you go. It worked. Let's try it again. This time, let's do the 2 flips. The first one was flipping over where y was equal to, I think it was 1, right? Is that what we said? Yes, over y is equal to 1. Watch where it shows you the line of reflection as it does that. And now we'll do the second one where we're going to reflect over where x is equal to 0, right? X is equal to 0 here. That's the line of reflection. And we got it into the puzzle in 2 moves. So this proves, using the online tool, that all that calculating that I did here was effective. It worked. All right. Now let's do challenge puzzle number 2. Go ahead and pause and take your time. This one's going to be a little trickier because I suppose you could go down and around and up. I decided in both of mine to go up and over and back down. Come up with 2 different moves that'll work there. And for this one, you can use online challenge puzzle number 2 to help you figure out what is the right set of moves. And remember, once you figure that out, please make sure you record it in your journal, all the moves and all the details. All right, so let's see. We're starting at C and we're going to D. So I think the first move that I chose to do would have been to get this guy up so that we can go to the right. All right, if I tried to go to the right first, it would just knock into the wall. So that's not going to work. And I could go over 1 or I could go over 2, but I think I'm just going to decide to slide this guy up 6 units. So 1, 2, 3, 4, 5, 6 units up. That was a random number. I could have gone up 5. I could have gone up 7 or 8. I just chose to go up 6. Doesn't really matter. And now, if I want to get this guy over here and reorient it, I think now's the time for a flip. So what line can I flip over? If I flip over the x-axis, that's going to put me 1, 2. That'll put me here, here, and here. If I flip it over where x is, did I say the x-axis? I meant the y-axis. That's where x is equal to 1. If I flip it over where, no, that's where x is equal to 0. I'm messing up terribly. But at least I'm catching it and correcting it, so that's good. Okay, so that's where x is equal to 0. This would be where x is equal to 1, which would mean we would get to here, right? Because this point would go 1, 2, 3 to get there, 1, 2, 3 to cross. So I think that's the move that we need to do. We need to flip it over where x is equal to 1. And so let me go ahead and do that now. Flip it from left to right, and then that ends up getting us here. And now it's just a matter of sliding it back down. It's just going to go down 1, 2, 3, 4 units. So x is not going to change. We're not going to move it right or left. We're just going to go down 4 units, -4. And that should work when I test that using the online tool. How about another way of getting this done? What else could we do? Well, I could start by flipping this guy up, and I decided, how about flipping it over where x or where y is equal to -2? If that's our line of reflection, then this goes 1, 2 to get there, 1, 2 to go across. This goes 2 to get there, 2 to cross. This one goes 1, 2, 3 to get there, so 3 to cross. So yeah, that looks as good as any. Let's go ahead and do that. So I'm going to flip this guy over. No, that's not what I said. I said flip it the right way, which would be up and down. That's it. Okay, so we move it to here. And then for my next move, I decided another flip over x was equal to 1. So let's move it to where is it going to go? If this is our line of reflection where x is equal to 1, then it's going to go 1, 2, 3 to get there, 3 across. This is going to take 5. No. How many? 1, 2, 3, 4. This is going to take 6 to get there. And so it's going to go 6 to get across. And then that one is going to do the same thing as well. So let's go ahead and flip that from left to right. And that's going to move us here. And are we ready for another flip? I think we are. This is a 3 flipper. So this one, what should be our line of reflection? I believe it has to be where y is equal to -1. And it is indeed where y is equal to -1. So we flip this guy one more time. And so every one of these is going to take 1 to get there, 1 to get down. This one's going to take 2 to get to the line of reflection, 2 to cross. This one's going to take 1 to get to the line of reflection, 1 to cross. So that is going to result And is this an up and down? It is an up. Stop it. Yes. And that's going to stop. Going to get us to right there. Okay. So I believe these moves work. Let's go ahead and test it with the online tool. For the first one, it said slide up 6 units. So we're going to slide it up. If I can get rid of that. 6 units. It brings us there. Then it said reflect it or flip it over where x is equal to 1. So let's flip it this way where x is equal to 1. And then the last step was to slide it down 4 units. So one more slide, x doesn't change, but y goes down by 4. And boom, that works. So go ahead and record that. That is absolutely the set of details, the set of moves that would work to get this into the right spot. Now let's try our 3 flip sequence where we flipped over y was equal to -2. Y was equal to -2. There's the flip. Then we flipped it over x was equal to 1. Let's do another flip where x is equal to 1. And then the last flip, I remember, was where y was equal to -1. No, it wasn't. Yes, it was. It was oh wait, that's from the previous one. Y is equal to negative, yeah, over that one. And congratulations to me, it worked. All right, so use those tools to help you out as we go. But eventually it would be good to just be able to do it paper pencil like I've shown you here. And that's going to take a little practice, but that's why we're doing it, right? Right. All right, so where does it stand? Felicia, this is our last problem, by the way. Felicia found a copy of a puzzle like the one in problem 6-1, but the lock is missing. All she has are the starting points and the moves to unlock the lock. This time her key is shaped like a triangle, okay? So here are the points where it starts, where point A is at -5, 0, point B is at -5, 3, and point C is at -1, 0. We are going to do a translation, a reflection, and a rotation for this original triangle. And each time we're going to chart on a coordinate grid the new image after each one of these transformations has taken place. So we're going to have to set up a coordinate grid. So this is why we have graph paper. You need to set up a coordinate grid, but think about these questions. How many quadrants should the graph have? Should we just do the first quadrant? Should we just do the upper half of the graph? And my suggestion is no, let's make sure that we create a 4-quadrant graph. And then how should it be scaled? What do you want your counting sequence to be like on your x and your y axis? And I'm going to suggest for all of these, we count by ones. Make intervals be equal to 1 unit, okay? So remember, we're going to start with step 1 where we do a translation. Then we are going to do step 2 where we do a, I think that's the rotation. I think, what's the rotation for number 2? No, that's the reflection over the x-axis. And then number 3 was the rotation. And along the way, it is saying to name the new location of each vertex, which means every single one of those points, point A, point B, point C, lands on a coordinate on the coordinate grid, and we need to identify the x, y coordinates of each one of those landing places. Okay, so let's start off by creating the coordinate grid. Go ahead and pause the video, and then plot each one of those 3 points. A is at -5, 0, B is at -5, 3, and C is at -1, 0, and label these as A, B, and C. You could also include the coordinates in there, but it's going to get really messy really quickly. So I just chose to do points A, B, and C. Okay, pause the video, go ahead and get this taken care of, and then we'll do each one of these one at a time. All right, so for step 1, it says translate 4 units to the right and 2 units up. So that would be a way of saying, wait, don't, let's get that a little thinner there. Okay, so for step 1, where you're going to take x and 4 units to the right is +4, right? 1, 2, 3, 4. You're increasing the x values of your coordinates by 4. and y is going to go up by 2. So if you think about it, this one is negative 5 plus 4 is going to end up being at negative 5, negative 1, negative 5, negative 1. No, what am I thinking? What am I thinking? No, 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 no. No. X is increasing by 4, so that's going to be negative 1. And then 2 goes 1, 2, 3, 4, 1, 2. This is going to be at point negative 1, 2, right? That would be point A. And for point B, increase that by negative 4, so that's going to be negative 1, and increase that by 2, that should be 5, right? So B is going to go 1, 2, 3, 4, and then 1, 2. Is that at negative 1, 5? Yes, it is. And then C is going to increase that by 4, so this is going to go 1, 2, 3, 4. So that's going to be where X is equal to 3, and Y is going to go up by 2. So 3, 2. Let's do that again. 1, 2, 3, 4, 1, 2. And now we've got a new triangle. Let me go ahead and color this in blue. We're going to connect those dots. And this is something that's kind of interesting, something for you to note. This is going to be point A, but it's now an image. So we're going to put a little tick mark in the upper right-hand corner. It does not mean A to the first power. It means the first image of A. This would be the first image of B, and this would be the first image of C. So technically, we'd want to put those marks here as well. Okay? Now, we are doing this in order. Okay? So now that we've got this new image, now we're going to reflect this over the x-axis where y is equal to 0. Okay? So I'm going to do this in green. And it says reflect it over the x-axis where y is equal to 0. So this is going to now be the second image of A. We're going to have the second image of B and the second image of C. Okay? So go ahead. This is our line of reflection. It is the x-axis. Every one of these points, however many units it takes you to get there, that's how many units you're going to go across. Okay, so go ahead, pause the video, and see if you can create that reflection, and identify what the coordinates are of each one of the points after you do that. All right, so this is what I've got for the reflection. Remember, A had to go, or the image of A went 2 units to get there, so 2 units beyond will be the second image of A, and so this is going to be where x is negative 1 and looks like y is equal to negative 2. For B, it had to go 1, 2, 3, 4, 5 units to get there, so we'll go 5 units across, and this is at negative 1, negative 5. And C had to go 2 units to go there to get there, 2 units to go beyond, so this is going to be at 3, negative 2. Now, there is a pattern that is emerging there. When you reflect over either the x or the y-axis, you will notice a pattern to what happens with the numbers. If you reflect over any other line, that pattern will not exist. So I tend to not teach the pattern, but if you notice something happening there, that was good. There is a pattern there. Now, why did I call that C? That is weird. Wasn't that supposed to be 2, step number 2? Yes, it was. All right, now for step number 3, which I have chosen to do in the lovely shade of purple. So now we're going to create the third image. And this, maybe I'll go down for these guys. The third image of A, B, and C. 1, 2, 3 tick marks. I'm going to get rid of this line of reflection that we used for part 2. And now let's go ahead and rotate 90 degrees about 0.3, negative 2. Where is 0.3, negative 2? That would be this point right there. That's your rotation point. Now, this might be tricky for you. So I am not going to pause the video and have you try and figure it out. Why don't you just go ahead and watch me do this, okay? The pivot point is the vertex, and if this guy rotates 90 degrees counterclockwise, that means it's going in this direction, right? Counterclockwise. And that means this guy, after the image, after rotating it, would form a right angle to this one. So I believe it's got to go down to here, right? And how long is this line? This one is 1, 2, 3, 4 units. So after rotating it 90 degrees, right? That's a 90-degree angle. It's got to be the same length as before because it's a rigid transformation. So I believe this guy is going to go right down to here, and this would be the third image of A. And B is going to have to do the same thing, but what I would just say is this. You know how this forms a right angle? Well, this has got to form the right angle here. So B has got to be 1, 2, 3 units away. 1, 2, 3 units. So this would be the image of B right here, the third image. And then C is just going to connect the dots. So now that I've got those in place, now I'm going to use my straight line tool. And stop it. We're going to do that. We're going to do this. We're going to change it to a lovely shade of purple. And then we're going to go down over to here. I'll fix this in a second because that's driving me nuts. There we go. That's much better. And then the last guy goes from here to here. And so this point is not only the image, the second image of C, but it's also the third image of C. So where are our points? A is now at 3, -6. That's a terrible 3. Much better. B is now at 6, -6, 6, -6. And C gets to stay where it was before because that was the pivot point, right? It's still at 3, -2. All right. I believe all of you can do translations with no trouble at all. Just sliding it at right angles, up and down, not a problem at all. The reflection, I think maybe you kind of get an idea of lines of symmetry, and so that one's not too bad. Definitely the rotations are the hardest part of all of this to do, okay? So that will require a little bit of practice. But as far as like testing you and assessing you on rotations, I don't feel comfortable doing that. I like testing you or assessing you on translations and reflections, but I feel like you've got a little bit of room to grow and learn a little bit more about rotations before I start assigning points on your ability to do that. I do want you to understand what a rotation is and how it works, okay? So that does it for this lesson. There is a check for understanding. So let's go ahead and do that and then complete your homework for lesson 6.1.2. All right, take care. Bye.
Hey, feeling good, like I should. When in